All right, welcome. Today, we're going to crack the code behind something you see literally every day, that beautiful, perfect arc of an object flying through the air. So, what could a perfect basketball shot possibly have in common with, say, the water from a fountain? I mean, at first glance, they seem totally different, right? But if you really look, they both follow the exact same elegant curve. So, what's the deal? What simple rule is behind this path that looks, well, pretty complex? To figure this out, we've got to look at the world a little differently. It turns out that what our eyes see as this one complicated motion is actually something way, way simpler going on under the hood. And here it is. This is the secret sauce. Every one of these complicated-looking arcs is just two really simple motions happening at the exact same time. This is the big idea that unlocks everything. You take a complex reality, like a ball flying through the air, and you just split it into simpler, easier-to-handle parts. It's a fundamental trick physicists use to understand, well, everything. Okay, so let's actually put this idea to the test. We're going to take the flight of an object and treat it like two totally separate stories, one for each direction it's moving. Yeah, think of it like this. We've got two independent stories happening. One story is just the up and down part of the journey, and the other story, that's the side-to-side part. The really cool thing, the magic really, is that these two stories happen completely independently of each other, but at the exact same time. So first things first, let's dive into that vertical story, the up and down motion. Turns out there's one single powerful and visible force that's the boss of this whole part of the trip. You see, in this vertical story, the object's speed isn't just changing randomly. Nope. It changes by the exact same amount every single second. And why? Because of the relentless pull of gravity. It's what we call constant acceleration. It's like a car's speedometer needle, moving just so smoothly and predictably, not all jumpy and erratic. And that constant acceleration has a number, a signature really. It's negative 9.8 meters per second squared. Now, that per second squared part might sound a little weird, but all it means is that for every second an object is in the air, its downward speed increases by 9.8 meters per second. And the negative sign? That just tells us it's accelerating down towards the Earth. Simple as that. Okay, that's story number one. Now, let's look at story number two, the horizontal motion, the steady cruise. And if the vertical story was this big drama of changing speeds, you'll find the horizontal story is, well, it's surprisingly different and a whole lot simpler. And here's the big difference, a big ol' zero. The horizontal acceleration is 0 meters per second squared. Now this is really important. If we ignore air resistance for a moment, once that object is flying, there's nothing pushing it or pulling it sideways. No force at all. And if there's no force, there's no acceleration. It's zero. And that's the punchline for our horizontal story. Zero acceleration means constant velocity. If there's no acceleration, the speed doesn't change. It means our object's forward speed just stays perfectly steady the entire time, from launch to landing. It's just cruising. So let's put it all together. This table really lays it out perfectly, doesn't it? For the vertical motion, you've got this constant acceleration from gravity, which means the velocity is always changing. But for the horizontal motion, zero acceleration, which means a perfectly constant velocity. It's these two totally different physics stories happening to the same object at the same time. That's the secret to the arc. Okay, so we've successfully split the motion into two separate stories. Now for the really fun part, let's bring them back together and see how they create that perfect arc we started with. This is where it all clicks. So how is the arc born? It's simple. Step one, the object is just cruising forward with its steady horizontal speed. Step two, at the exact same time, gravity is pulling it down, making it fall faster and faster vertically. You combine these two independent motions at every single instant, and what do you get? A perfect parabola. It's just these two simple movements, one layered right on top of the other. And that's really the heart of it. That parabolic curve is just the signature of these two simple, independent motions working together. It's the result of combining a steady, straight-line cruise with a downward freefall. And trust me, once you see it this way, you'll start seeing it everywhere. And this idea isn't just some abstract thing for a physics textbook, you know? It's the hidden rule behind tons of stuff we see and do in the world, every single day. I mean, you really do see this physics everywhere. Think about it. A video game designer making a character's jump look realistic? They're using this. A quarterback figuring out the perfect throw, they're using this. Even an engineer designing a water fountain display, they are all, whether they know it or not, working with these exact same principles. Understanding this stuff is how we predict and control motion, from making fun games to literally exploring space.
So, it makes you wonder, right? If emotion we see every day follows these simple, separate rules, what other really complex systems in our world are just waiting for us to understand them by splitting them apart? And that's what's so cool about physics. It gives you a new lens to see the hidden simplicity in a really complex world. It teaches you to look at any big problem and ask that one simple question. Can I break this down into smaller, simpler stories? It's an incredibly powerful way of thinking, not just for a basketball shot, but for making sense of pretty much everything. Thanks so much for joining me.